Today we're going to look at absolute value functions. Absolute value functions are kind of an interesting function on the graph. If we graph this using a table, I'm going to draw this table in, and I'm going to use -2, -1, 0, 1, and 2. If we plug those x values in, plug -2 into there, what is the absolute value of -2? +2. What is the absolute value of -1? +1. Absolute value of 0 is 0. What's the absolute value of +1? +1. Absolute value of 2 is 2. Do you notice that everything in that y column is positive numbers? Because absolute value creates positive numbers. Now if we graph these, -2, 2 is right here. -1, 1, 0, 0, 1, 1, and 2, 2. This is a V shape. It's kind of like the line y equals x. You might notice that this piece of the line looks like the equation y equals x, but the negative half of that line got flipped up into the positive quadrant because absolute value makes things positive. So it's like the line y equals x just got bent up to make a V. So this other one, y equals 2 times the absolute value of x, is kind of going to look like, I'm going to write this, kind of like y equals 2x. What would the equation y equals 2x look like? We'd start at 0, 0. We'd have a slope of 2, so up 2, right 1. The absolute value function is going to be symmetrical over that y-intercept, over that vertex. So up to left 1 and up to left 1. I want to show you how to do this in the graphing calculator if you want to. Y equals is where we go to graph. Clear out anything that's already there. Then you push the math button, which is directly below the alpha button. Oops, not that one. That one. Right arrow once over to the NUM part. And the very first option is ABS. ABS means absolute value. And on newer calculators, it will pop up absolute value bars exactly the way that they need to be, and you just have to fill it in. So if I want the absolute value of x, and then I graph it, there's the first one that we graphed. That's the line, basically y equals x. I can go back in here, and in front of that bar, I can stick 2 times the absolute value of x. And there's the one that we just graphed, y equals 2 times the absolute value of x. Okay. The next one we're going to graph is y equals 1/2 times the absolute value of x. This is still going to start at 0, 0. And it's kind of like it has a slope of 1/2. So it starts at 0, 0, and from that point, that's the tip of the V, it's going to go up 1, out 2, up 1, out 2, in both directions to make the V. So up 1, right 2, but also up 1, left 2, up 1, out 2. Continue this if we wanted to. Okay, so far looking at these, what do you think the number in front of the absolute value bar does to the graph? How would you compare number 2 to number 1? Is it the slope? Would you call it wider or narrower? That one's narrower or more narrow. We're going to say narrower is a word for now. And then number 3 looks wider. Anyone want to take a guess what you think might happen if we put a negative in front of that too? It'll flip. So this is going to flip and it will have a slope of -2. Now, do you see how I'm writing slope in quotations? Because it's not really the slope, but it kind of is. So we're starting at 0, 0. We're going to go down to out 1. Down to out 1. And do you see how this graph is symmetrical? So whatever we do on one side of the vertex, we do on the other side of the vertex as well. That was not a very good line. Okay, what effect does the number multiplied to the absolute value have on the graph? So this A value in front of the graph. If A is bigger than 1, it is called a stretch, and it makes the graph more narrow. Like when A was 2. If it was 3, it would have a slope of 3. If the slope is steeper, it's going to be more narrow. If A is between 0 and 1, like in 1/2, it's called a shrink. And that's where it gets wider. Think of stretch like you're taking Play-Doh and you're pulling it vertically. You're stretching it and making it skinnier and more narrow. Think of a shrink as you're taking the Play-Doh and you're smashing it with your hands vertically. That's going to flatten it out and make it look wider. Okay. On the next page, we're going to look at what happens if we add or subtract numbers inside those absolute value bars. And I'm going to help us out a little bit. And I'm going to graph the absolute value of x as blue. And then this one, I'm going to put the absolute value of x minus 3. Anyone want to take a guess before I graph these, what that minus 3 might do? Any guesses? Okay, let's see what happens. I push the graph button. There's my original, and there's my new one. The red one is the new one. Do they look pretty similar? What's the only difference? My first hour is dead on a Monday morning. It moved right 3. So this minus 3 moved the graph right 3. Is that kind of weird that minus moved the graph to the right? Yeah, that's kind of weird. So we're going to start at 3 on the x-axis. That's where that vertex is. And then it's a slope of 1. There's not a number in front of the absolute value bars, so this is just a normal slope of 1. And I know it looks a little different on my screen. Hold on. Okay, I changed my window, so now these squares look a little bit more similar to the squares on my graph. So if the minus 3 moved the graph to the right, what do you think plus 3 is going to do? Move the graph to the left. So over here, this time I'm going to make it x plus 3 and graph it. And the new one is now to the left. So this is left 3. But then a slope of 1. So up 1, out 1 to make the V shape. So at the bottom of that page, what effect does a number added or subtracted from the x have on the graph? It shifts the graph left or right. And I want you to put a plus sign with the left and a minus sign with the right. See, this is so messed up that sometimes I even screw it up. So what I want you to remember is inside the absolute value bars is crazy town backwards world. So a minus means right and a plus means left. It's opposite of what you would assume. Now we're going to look at going outside of the absolute value bars. What happens if you add or subtract numbers outside of the absolute value bars? So this time I'm going to get rid of the plus 3 inside there. Oops. I want absolute value of x, and then I want plus 2. What do you guys think is going to happen? Okay. What happened? Up 2. And that's normal, right? Plus means up. That kind of makes sense. So this one went up 2. So if you see a plus 2 outside of the absolute value bars, that means instead of starting at 0, 0, we're going to start up 2 from the origin. And then it's going to be the normal slope of 1 to make that V shape.
On problem like these, are they always going to be the slope?
Question was, is it always going to be a slope of 1? No, not always, but for right now, just to make them easier to graph, we're doing slope of 1, where the only difference is how it's moving up, down, left, right, whatever. So if plus 2 outside of the absolute value bars moved the graph up 2, what do you assume that this minus 2 is going to do? Down 2. And we can check that in the graphing calculator. If I change that plus to a minus, it moved the graph down 2. So now from the origin, we go down 2, and then up 1, out 1 from that vertex. So what effect does the number added or subtracted from the absolute value have on the graph? And if you see, that's this plus k, plus moves the graph up, minus moves the graph down. So basically all we're doing today is shifting left, right, up, down, and then stretching or shrinking. And for your assignment today, I do want you to look at the top of the next page. At this equation. So I'm going to write that a little bit bigger. Because this is basically on your assignment today, it's going to give you a graph and it's going to ask you, what are the characteristics of this graph? So A is responsible for any stretches or shrinks. And I think we'll actually do one problem on your assignment together. The minus h is left or right. So I'm going to say left, right, and left was plus, right was minus, because horizontal movement is backwards. And then the plus k tells you if you are moving up or down. Plus was up, minus was down. So if you have that written on your paper, you should be good for the assignment. A stretch is going to be more narrow, so I'm going to put an N next to that for more narrow. A shrink is when it's wider. When you go to Schoology and click on B2.8 worksheet number 1, it's going to look like this. You're going to click to start the attempt. When you get into this assignment, down at the bottom, you can pick which number. There's 5 problems to do. We're going to do number 5 together. So if you click on number 5, first we need to think about how does this move horizontally. So the plus 1 means left 1, plus 4, up 4. There's a 1 in front, so that's a neither for stretch or shrink. And the negative flips the graph, so that means it opens down.